Namaste, you are listening to Apna Gurukul Maths and we are discussing the chapter Number System, chapter number 1 NCERT class 9. We have discussed almost all the topics of this particular chapter. We are left with two more topics. So the number one is what happens when we do the square root of real numbers and how do we plot them. So I hope you are very much clear with the concept of square root of numbers. We did a few identities as well in the previous video, and in the previous video, we had done some operations on real numbers as well. I hope you are very much clear with that. If not, I have the playlist in my description. You can go there, you can refer all those videos. If you have a little bit confusion, that will make it much more clear for you. Okay, then I hope you are clear with plotting natural numbers. So it's, I guess, second or third video, we have discussed this concept, that square root spiral I showed you with Geogebra as well. But then comes, how do we plot real numbers? That is what we're going to discuss now. Before that, let's begin with an amazing quotation. The only way to learn mathematics is to do mathematics. I repeat, the only way to learn mathematics is to do mathematics. If you just keep on reading and reading, if you just keep watching my videos as well, it won't help you the maximum until you start doing it yourself, until you start practicing and observing things by yourself. This is given by Paul Halmos. Now, coming to the definition of square root, it's a very popular definition if we are discussing only about natural numbers or rational numbers even. So if a is a natural number, then square root of a equals b means square root of a equals b. What is the meaning of that is b square equals a, where b is greater than 0. Why do I say that is when we have square root of a equals b, you just square it on both the sides. So we have already discussed when you square an under root, you get a, and when you square it on, I will write that step. Square root of a square equals b square. That implies square root of a square is a, that is equals b square, and that is what we have written in the definition. Now, why is b greater than 0? Because square root of any possible real number or even natural number, over here it's natural number, can never be a negative number. So that is the reason b is always greater than 0. Now when we extend this definition for real number, we just change the variable. If square root of x equals b, where x is a real number, then the meaning of that is b square equals x, where b is once again greater than 0. B can never be less than 0 until and unless x is a real number. Okay, now you might be thinking, can b, is there a possibility that b is less than 0? My dear friends, there is a possibility, but please don't think about that right now. That comes in class 11th, which is called complex number. So let's now understand, once we have understood what is a square root, let's try to focus on how do we plot any square root of real number on the number line. Okay, now generally I first discuss the proof of the process and then discuss the process, but in this case we will understand the process first and then we will try to prove why this process works. Okay, let's begin. So first thing we are doing is we will plot. That's the first step, right? We'll draw a line of 4.5 centimeters. So we are making square root of 4.5. So the first step is make a line which is of 4.5 centimeters. So 4.5 centimeters, I have made it. Then what is the next step? The next step says draw a line from B. Oh, this is B. From B, make a line of 1 centimeter. That makes it BC. I will name it after a little while. So we have to, from this point, we have to make a line of 1 centimeter. So I have made it into a little bold so that it's very clear to recognize, right? So now I will move the scale and I will do some naming. Okay, so let's mark these points. This is A, this is B, and this one is C point. So I will mark it A, this one is B, and this one is C. Yep, I hope that makes sense. Now, what is the next step? Find the midpoint O of AC. So we have to find the midpoint of O, like we will represent the midpoint by O. Now that is a very, very important concept we must always remember. So how do we do that? We will do it with the help of scale. Now there's one thing you can do. You can either measure the length of AC by the scale and then try to find the midpoint. But we will try to understand a little more geometrical way. So what do? Is we take a compass, we have to find the midpoint of AC, right? So we put the compass on one of the endpoints that we over here we put on A, and then what do? Is we will fix this compass so that it is greater than the midpoint. Now approximately greater, I'm not saying that you have to find the midpoint directly. So over here I'll take it as 4 centimeter. Now I have measured it because I have to keep it fixed until we have done with this finding midpoint. Now we make a circle over here. Now you can just make an arc over here on top and bottom also, that is your choice. Now after this, move to the C point, and then once again with the same. We are not, mind it, my friends, we are not changing the length of the compass throughout the process. Okay. Now we will remove the compass. As you can see, both the circles are meeting at a point. We will connect this point with a straight line, and then the straight line meeting at this position, right? So this will be called as O. Okay. Now, what is the O? O is the midpoint of AC. Now, you might be thinking, how can I be so sure? So let's try to guess, verify. So now we have the line AC is how much? AB is 4.5. So AC will be obviously 4.5 plus 1, that is 5.5. Now, if you have to find half of 5.5, you just divide it by 2, you get 2.75. That means the if you measure it with scale, it should be between 2.7 and 2. See, exactly it is between 2.7 and 2.8. So that means whatever process we have followed, it is absolutely correct. Now, why does that process work? All those reasons we will try to take it later. But for now, once we have drawn this midpoint, you can erase all these lines. That's your wish. You can leave it as well. That's not a big issue. But since I have to explain it, I will erase it. So now we have got the midpoint, which is O. I will make it a little more circular point. Yes. So this becomes O. Now what we have to do, focus. Now draw a line perpendicular to AC through B. Right? Wait. Draw a semicircle with center O and radius OC. Now we will take back this. The center is O, and we are taking it the radius as OC, and then we will draw a semicircle. Okay. Shall I change the line? Okay, I'll change the color of this so that it becomes much more clear. So what we are doing, we are drawing a semicircle. As you can see, it is exactly meeting at A, right? So now, once we have done this, what is the next step? Draw a line perpendicular to AC through B. Now what we have to draw a line which is perpendicular to AC, which is passing through B, right? So what we will do is on the B, we will put the compass, right? Protractor. I hope you know how to measure the angles with the help of protractor. So we have put the midpoint of the protractor over here, as you can see, where on the point B, wherever you have to mark the angle, you have to keep the protractor's midpoint over there. Then you can see we have overlap the bottom line, and then we will measure 90 degree and put a point over here. Wait. This is not 90. Yes, this is exactly 90. Now, once this is done, we will remove the protractor. We will mark a straight line from here till BC. Now this till B. Now, this particular line is a perpendicular line from AC, which is also passing the B. After this, what we do? We mark this particular point and the intersection of the semicircle and this particular line. So this becomes D. I hope that makes sense, right? Now, we don't need this right now. Now what we will do is we'll take back the compass once again. We will plot it, keep it on B, and then we take the radius now as BD, right? And then we draw an arc on that, right? Now this arc, wherever it intersect on the number line, it will represent the point which we are requiring, that is square root of 5. That means this particular line which we drew, BD, is nothing but square root of 4.5. So when I take that as a radius, it will also represent it on the number line. So what do? We draw the number line. Now, since we are drawing the number line, you must be very careful that the line of this number line should start, the zero of this number line should start from B point. Why? Because we are measuring root 4.5 from this B. So now, as you can see, the intersection point on the number line on this particular arc, this particular point is representing square root of 4.5. Yes, so that will give you the square root 4.5 on the number line, and we have represented square root 4.5 on the number line. I hope that makes a lot of sense. Yes, the process is clear. If not, you can just go back, go through it once again. You will understand it. If you have any doubt, you can comment down, and we will get back and discuss on that. Right? So let's move to the next concept, which next thing which I told. We will try to prove it. How does that work? And then we will verify it. Now, verify with root 9. Root 9 is nothing but 3, right? So we will follow this exact process, plot root 3 on the number line, and then see whether are we getting that on the number line at the position 3. Yeah, let's prove this process once again. Now this is the exact same figure which we got. Now we told that this is nothing but square root of x. So what we have done, we have taken AB as x. So AB as x, what was the first step? AB, we took whatever we had to prove, right? 4.5. We have to prove roots 4.5. So we took AB as 4.5. So here we have taken AB as x. That means we have to plot square root of AB. Yes, square root of x, I mean. I'm sorry. Square root of x. Now, according to the final result of the process, this BD was square root of 4.5. That means over here also BD equals square root of x units. That is what we have to prove it. Yes, I will write it as to prove. If we are able to prove that, we are done with the answer. What is given to us? That AB is equals to x and x unit. That is what we have taken. BC is 1 units. Yeah, I'll write just units quickly. And then AB is given to be x units. Yes. So now be very, very careful, my dear friends. So what will be the length of AC? Obviously, it will be x plus 1 because AB is x, BC is 1. So AC is nothing but AB plus BC, right? AB plus BC gives us AC, right? AC is the bigger line. So that makes it x plus 1 units. Now, what will be the length of AO or OC? Now, since O is the midpoint of AC, AO equals OC. Yes, that means the length of AO will be half of AC. So that makes it x plus 1 divided by 2. Why does that so? Why does that so? Because midpoint is nothing but the point which divides the line segment into two halves. So if you want to find the value of half of the length, we just do x plus 1 divided by 2. And similarly, OC is also equal to x plus 1 by 2. Now, what will be the value of OD? Now, as you can see, since we drew this semicircle, this pink color semicircle, with the help of O as the center and OC as the radius, OD is also the radius, right? Because it is connecting the circumference of the semicircle and the center. So this will also be the radius. So that makes OD also x plus 1 by 2. Now do not write it as x. Do not write it this way. Okay, they both are completely different things. So please don't get confused. Now, I hope till that part it is clear. Then, what will be the value of OB? Now, listen to me very carefully. Can I write OC equals OB plus BC? Look at the diagram. Pause the video. Look at the diagram. I hope it's clear. Now, we already know OC equals x plus 1 by 2. Yes. And OB we have to try to calculate. And we already know the value of BC is 1 because we have taken that, that is the step we have followed. Now if we have to find OB, we'll take this 1 to this side. So this becomes x plus 1 by 2 minus 1 equals OB. When you solve for OB, you get x plus 1 by 2 minus 1. Can I write it as 2 by 2? Because I want to make the denominator same. That is equals to OB. And that gives us OB equals x plus 1 minus 2 by 2. And that gives us x minus 1 by 2. I hope that is very, very much clear for all of you. So that gives us OB is equals x minus 1 by 2. Now pause the video. I request for you, try to go through everything, whatever we have done so far. Just try to analyze it. I hope you are very much clear. Let's now move on. Why are we finding all these lengths? Because now I'm going to use Pythagoras theorem. So in triangle ODB, we know that at angle B we have a 90-degree forming on, because that is what we did. We did that in the problem also, right? So this is a 90-degree. That means it's a right angle triangle. That means the hypotenuse is OD. So in triangle ODB, OD square is equals OB square plus BD square. I hope that makes a lot of sense. Yes. So now we know the value of OB and we know the value of BD also. We have to find the value of BD and we also know the value of OD, and that is why I was finding all these values. You understand? To apply that in the Pythagoras theorem. Okay, so now we have to find the value of BD. So I'll keep BD square is equals OD square minus OB square. Can I do that? I'm just taking this OB square to the other side and BD square remains this. This is positive, so when it goes to the other side, it becomes negative. So that is equals. Now I'll put the values which we have calculated by so much hard work and thinking. So OD is nothing but x plus 1 by 2. So we will make it a square of that, minus OB square is x minus 1 by 2, and then to the whole square, right? We have calculated OB as x minus 1 by 2, right? As you can see it over here, x minus 1 by 2. So we will make a whole square over here. Yep. Let's get going. Now BD square is equals this. Now we will solve only the right hand side. We will keep BD square as it is. So x plus 1 if whole square, if you are doing, the numerator becomes x square plus 1 plus 2x divided by 2 square is 4, minus, if we solve the x minus whole square, that becomes x square plus 1 minus 2x, and that becomes perfect. That is also divided by 4. Now as the denominator is already the same, can I further operate in the numerator only? So this becomes x square plus 1 plus 2x, my dear friends. Now observe, we are subtracting two algebraic expression. So the expression which is after subtraction, all of its sign will change. That is why I have taken one more step so that I can make it very, very clear for you. So this becomes x square plus 1 plus 2x minus x square minus 1 plus 2x divided by 4. So this x square and x square gets cancelled, plus 1 and minus 1. X square and minus x square get cancelled, plus 1 and minus 1 gets cancelled. So we are left with 2x plus 2x, that gives us 4x divided by 4, and 4 we can simplify. So what are we left with? We are left with BD square equals 4 units. What does that mean? I'm sorry. Why did I write 4 units? It's x units, right? X units. So what will be BD? BD will be square root of x units. If you want to understand this part, go to the definition. You will understand it very, very clearly. Or you can just simply, we are taking square root on both sides. So square root and square get cancelled out. We are left with square root of x units. And what did we prove? We just proved that the length of BD is square root of x. Yes, that is what we did in this process also, right? We plotted AB, which is nothing but x we took here. So this line BD gave us square root of 4.5. Yes, I hope that is clear. If not, go back, go through this process once again. Yes. Now we will try to verify square root of 9. Now this is an extra part which I am doing to make it much more clear. Okay, if you think that you have already understood, you can skip this part and you can go to the next video. Yes, so now I will mark from here to 9, and then what is the next step? The next step says you have to the next step was from A, V, this is AB, right? From B point, mark a 1 centimeter, which makes it BC. The length of that is 1 centimeter. So I will name it all. This becomes A, B, and C, where BC is 1 unit and AC is 9, because we start with 9 because we have to plot square root 9. I hope that is clear. Now what do? We find the midpoint of AC. Now you can follow the geometric process. That is a very, very effective and good process. Now to make it a little faster, I will use the scale itself. Scale is easier, but when you have in decimals, scale becomes a limitation. I have taken here it becomes 10, so 10 divided by 2, 5. So I can use the scale. Now every time the process with the protractor is always efficient, you can use it. Okay, so let's try to verify that also. Okay, why will take some time. Okay, so this becomes the midpoint. So I'll mark the midpoint O. Okay, and now I'll try to verify this by measuring the midpoint with the help of the compass. Okay, that is going to be interesting. I just got that idea. I never planned that, but yeah, I got that idea. So what was the thing? Take it approximately greater than, you can take anywhere over here. You can take it nearby. Okay, and then I'll make a circle out of this. Now the circle is going a little bigger. I'll not complete the circle because I require only half of the circle over here. And now I will again draw this circle. Yes. Now, as you can see, I have found the midpoint. I will connect this midpoint. I'll just make it a little bit. Yes. I will remove this scale out of here. Yes. Now, as you can see, here is the midpoint. I'll connect it. It is going exactly from this particular line. That means the process we are doing is absolutely correct. Now I can erase all of them because I have found the midpoint. I was more worried about the midpoint. Now let's bring back the compass once again. Compass. And then what is the next step? The next step is take the O as center and OC as the radius and plot a semicircle. What was the next step? The next step was take a 90-degree line, a line which is 90 degree from AC or perpendicular to AC, and draw that line. Why we are drawing that line? Because we have to find the intersection of this line on the semicircle. So now we connect these 2 points and it is intersecting over here. We name this point as BD, and this BD will be root 9 units. Let's try to verify that with the help of scale. So we will try to plot it on the number line. So I'll bring the number line. Dun, dun, dun. The number line comes here, and then we bring the number line on this O. Now I hope you are very much clear with why am I putting the 0 on always on B, because we have to start measuring from the point B, right? Because we are taking B as the center while we are making the arc to plot root 9. That is why we take it. Now we will take it, and that's how we make it. See, exactly it is passing through 3. Yes, so square root of 9 is 3, and as you saw, this process gave us this point 3 as it means exact point. That means whatever process we have discussed, whatever we have proved, and whatever we have understood, it is absolutely correct according to mathematics, right? I hope that makes a lot of sense. I hope you are very, very much clear with the concept. How do we plot a square root of real number on the number line with this process? Thank you so much for listening to Apna Gurukul Maths, one step towards success. And obviously, I'm just trying to make it more and more conceptual so that our concepts of mathematics becomes clear. Thank you so much for listening. We'll see you in the next video. Until then, keep smiling. Jai Hind.